When I start with Drillholes, my Drillhole logic is slightly different from some of the other software packages, and there's a reason for that. The reason for that is that it also aligns with some of these line tools, like these tools you see over here. So I keep the format between the Drillholes and the line tools the same, because that enables us then afterwards to move between the lines function and the Drillholes function. And then you can basically then generate Drillholes by using the lines tool and just create lines. So that helps you to, for example, do mapping in your underground area and so forth. So I'm not going to go into the details. Let's start in the Drillholes. So when you do your Drillholes, there's two basic files that you definitely need to progress on anything. And then the third one is the data file that you normally would need, depending on what your purpose is. So you need the collars, then you need the surveys, and then you need the geotech files. And what's sometimes confusing to some is the fact that I split up the survey lines between create survey and load survey, and I do the same with geotech lines. I split it up between create geotech and load geotech. And the difference is, or the way I differentiated, or the reason I differentiated was, when you create your survey, you create a standalone survey file in my format, which you can then afterwards load with load survey. And the same with create geotech, you create the geotech file in my format, which I will show, and then afterwards you can directly load that file without having to load the collars or the survey lines beforehand. So let's start with the collars. So when you load the collar files, the file format for collars are really simple. So I'll open it up in Excel, just so you can see the format. So the format for a collar file is just the Drillhole ID, then the easting, northing RL, and it has to have a depth as well. So that's really simple. You can also, if you want to have a look at the format, and if you go to the Drillholes and the collar, and then the collar, if you go to the collar data grid, that will show you all the values that you need for that particular file. So let's load the collar files. So that's just points in space that you can then investigate. So now you've got your collar files. So that's simple. That's just points. What you now need is the survey files. Now, the survey file doesn't give you any information about the location of that particular point. So you need the collar file, which contains the directional data, and that's then connected to the coordinates of the collar file to create the full survey file. So that's the file that you then import: Drillhole ID, depth, dip, and bearing or azimuth. In my software, dip is always before azimuth or bearing, and dip direction. So dip always comes first. So I standardize it across the package. So I load the survey file. Now, when you load the survey file, there's one thing to just take note about, that we use we define dip the opposite way than the way geology defines dip. So when we look at dip, we look at horizontal as 0, and as you drop your arm down, so if you keep your arm at the horizontal plane, you drop it down. For us in geotech, that's positive, but for geology, that's negative. So that's why there's some options that you have to select as you go through this process, because it depends on who was creating this initial file, on what selection you have to make. So what I normally do is, because I'm now creating what I call my survey lines file, I'm going to call it survey lines. I'll just overwrite that file. So you'll see now in the survey column under the data, you now have a survey lines file, and you see the format is very similar to the marker format, the mapping format, all the other formats. All you have that's different is in a marker file, each point, for example, is just defined by a coordinate, X, Y, Z. While in this case, each of these points are defined by, well, each one of these rows define 2 points. So it's an X, Y, Z for the first point, and then an X, Y, Z for the second point. So it's just from this point to that point, and there's a whole bunch of properties then associated to that line. So it's very similar to a marker or mapping data. The only difference is, instead of one coordinate, you've got 2 coordinates, and then it splits it out in that format. So now you've got your survey. So the next step is to generate your geotechnical data. So you start again, create geotechnical data, and your geotechnical data format, I'll just open up that file as well. So your geotechnical data file is just, the common denominator for all these files is the Drillhole ID, so that needs to be exactly the same. If you use a space in the one file, you have to use a space in the other file, and so on. It has to be exactly the same. And then you need the from and the to's, and then a whole bunch of data. So it doesn't matter how many data columns comes after. But it's only the first 3 columns that's actually required to create the next step of the file. So when I select this again, it's gonna ask me for a file name, and I just normally, if the file was called GTech, I'll just call it GTech lines. So that's now my GTech lines file. So now I've got the file, and as always, the default coloration is done on depth. So that's, I think it's on depth in this case. Now in this case, it's on from. So you'll see the 0 is from. So that 0 then coincides with that 0, and you can cycle through the data columns and color it as you go along with as always, you get your histogram down the bottom and your statistics on the right bottom side. But this data you've got up to this point is really lines data. So if I zoom in close, it's still lines. It's not points that's close together, it's lines. Now, what we need to do from this point onwards is create points from it. And why do we want to create points? You want to create points so you can bring it back as markers, because when you've got it as markers, you've got a whole bunch of other functionality you can use, like isosurfaces and coloring your meshes and so on, which is not available in this Drillhole function. So the next step is, I've got my geotechnical data. I want to now composite the data, and all the composite is doing, it just runs along each line, and it will create a data point on that line based on the interval that you specify. So if I press the button, it will ask me for an increment distance. 1 meter is quite common. If you're in America and all the information you bring in is in feet, it will be 1 feet. And you say accept, and it will ask you for a file. So I'll call it my composites file. So I'll overwrite the composites file. So when I now load the composites file, that will be not the lines data anymore, that will now be marker data. So I'm going to kill all this data. So I got to scene, reset all. And then I'm going to load that composite file that I've generated. I'm just going to load the composites file, and it's now not in the suspected format. Why not? Because I load the wrong file. So there's my composites data. So I now loaded that composites data as a marker file. It's currently color coded on 0, which is elevation. Let's color code it on RQD. So I'll go to column number 3, RQD. And you can see, if you look at this, the histogram down the bottom, most of the values are between 80 and 100. So you can see where the mass of your data sits. And there's your statistics that goes with that particular data set. So what it's doing at the moment is automatically selecting the lowest value, which is 10, and it's automatically selecting the highest value, which is 140, which is higher than it should be. So what I'll do is, well, the first thing you can do, you can maybe go to this column and say, I want to filter out all the data above 100 because I don't believe those data, or 105, whatever your choice is. So I'm only going to look at, it should be less than or equal than 100. So the other data points are now removed. So now you can see the starting value is at 10 and the end value is at 100. But because all these values are so close together, I could maybe say, instead of an automatic selection, let's go for a manual selection, and I'll start at maybe 90. So all the rock is really good, but now I get a good differentiation between my different rock mass properties. And you can see, although all the data is really good, there's a clear distinction between the values down the bottom and the values at the top. So there's a clear differential. Although it's not a big differential, there's a clear differential. And why would you like to do this? And this is not going to be a good isosurface, but because you've got data, you can now use isosurfaces. Oh, and this is going to be really bad because the data is very unequally spaced. So what I'll do is I'll just filter out some of the data to look at a smaller data set. So I'm going to do it manually. Now you've seen that you can do your filtering in the grid. So that's one way of filtering. The second way of filtering is going to markers, then marker filters, go to manual, and then say, let's remove all the information outside my selection. Now, this is going to force me into something called parallel view, which I explained in my previous video, so I'm not going to explain it again. So I'll make my selection. So all the information inside the selection is remaining, the rest is out. If I now do an isosurface, it should be slightly better. So let's have a look. So I get some isosurface, not perfect. I can maybe change some of the settings and see if that gives me a better answer. I'll maybe go make this one slightly bigger. So there's some parameters you can change. You can update, see if that gives you a better value. In this particular case, I'm not sure it's going to. But what you'll still see is what the isosurface is able to do. It's able to differentiate between my cool colors over this side and my warm colors over that side. And the reason it's struggling to create a nice isosurface is because you've got a concentration of data on the one side and a concentration of data on the other side, and then a lack of data in between the two sets. So anyway, so that's the reason you want to take your drill holes, bring it across to composites, and then use the composites, because that's normally the useful data that we then use going forward with the statistics and the histograms and so on that we would like to use. Any questions on drill holes before I tackle the next topic?
Yes, Frans, Rian here. Just a quick question. I suppose then I sent you a previous email to ask, can you delete if you, sometimes you get a database and the geologist gives you 1,000 drill holes, but you're only really interested in a small population within that, and to filter that out manually is difficult to do.
Yes.
So is it, and am I then right if I then change it to markers and use this functionality to select only certain data? Is there a way to filter out certain of the boreholes that I can then, and then, you know, from the left-hand bottom screen, just right-click and save that as a separate file?
Yes, so at the moment, thanks, Kriyan. So at the moment, under drill holes and under collars, there's no filtering option there. So what I would have done in your case, I would have just temporarily changed the format of the data. So I just bring the collars to the front, the collars, the coordinates, the east to northern elevation. So I take the collar file, bring the coordinates to the front, load them as a marker file. Then I can use the marker file, and I can within the grid select them out, or I can use these marker functions with all these options to filter out the specific markers that I need or drills that I want. I'll then, after I've filtered them out, you right click and you say save that as a separate CSV file. You take that file, reorder your columns again, so it's in the format requested for the collars, and then that's all you'll only have those columns. Because if there's a survey file that you load without the collar, if the collar information is not available, that survey row is just ignored, so it's not loaded.
Okay, thanks, Frans. That's great help.
Sure. Any other questions?
Enoch
yes.
Here.
Yes, Enoch.
I have a question. So, during compositing,
yes,
in one of the dialog boxes is the incremental distance. What should guide you in selecting appropriate incremental distance, as these points are created spatially on the distance you would select?
If you've got a very small data set, you know, and the people that did the logging did it on a very granular level, so they could have like maybe 30 centimeter intervals between different rock mass properties, then you can use a far smaller value to capture that subtleties within the data. But in large data sets and on a mine-wide scale, you'll seldom go below 1 meter intervals. Because it's seldom, because most of the stopes we're mining is significantly larger than a meter, so that granular scale is not always important. So it depends on the application of your assessment. But I would say in general, 1 meter works well. I nearly always, I can't think of any case where I haven't used 1 meter.
Thank you, Frans.
Is that answering the question, Enoch?
Yes, please, Frans.
Sure. Any other questions?
Frans, this is Michelle.
Yes, Michelle.
Okay, I wanted to find out, earlier on in your presentation, you were like, because the depth direction changes from what the geology gives to us and what we pick. I wanted to find out if you can initially, before you load the file, if you can just put in the negatives to those one you think should be changed, and will it work? Should you use the negatives? Will it work?
Absolutely, I've done it a lot. Where you change the data within Excel beforehand, before you load the data. Absolutely, you can do that. Yes. So there's a lot of times, Michelle, when we would manipulate the data in Excel and then bring it back in GEM4D. Cobus Deploy and his team does it plenty. At Anglo Gold Ashanti team does it lots. Work between Excel and GEM4D. So no problem doing that. Yes.
And I want to find out, are there shortcomings? Is there a possible way that maybe with lots of data, you get some of the holes rather, should I say, redirected to another different dip, since you're including the negatives? Is that possible?
Yeah.
Like when you when you input the negative values,
yes,
does it affect the quality of the data? As in, maybe you get some of the holes not exact as what you thought it could be.
If you change the sign of the data, that should not affect the data quality at all. The only complication could come in is if your database that you've got is not consistent. So if some is done in a geotechnical interpretation and some is done in the geological interpretation, that will be very difficult to then fix afterwards. But just changing the signs will not change the data quality now.
Okay, thank you.
Okay, sure. Any other questions on Drillhole specific? Okay, then I'll move across to, we'll start with ERF and then HR calculations. The two are slightly different. They give a similar value. It's not the same value, so just be careful. What you get, development ERF. So what you get with ERF and what you get with HR is not the same value. There was a time when I thought it's very close to the same. It's not the same, but it's very similar type of data. But I'm not going to go into how you calculate ERF. I think most of you know you shoot out radial lines across each one of those points, and then you measure those distances. And what's nice about this can give you, well, the type of visual that I'll show you shortly, which is not possible with HR. So for the ERF calculation, what you do, you're just going to create basically a clipping, because the clipping is going to be the plane on which this ERF calculation is done. So an ERF calculation can only be done on a flat plane. So you cannot do an ERF calculation on a curved plane. It has to be a flat plane, and that's a bit of a limitation, but that's the way, or that's what we need to work with. So I'm going to take this horizontal development. I'm going to select the center point in the middle of this intersection that I'm interested in. I'm going to do a clipping that's done on horizontal. So I'm going to do a horizontal clipping, and I'm going to do it with lines so you can see. So the outputs I'm going to get is going to give me a good output in this area. And then because the development is not perfectly flat, it's going to give me some information on the left-hand side that I won't be able to use as well. But that's fine, I think, for our application. So all you have to do, you create yourself this section to define the plane. That's all you do, is define the plane. Then you go to mesh and you go to export files and you say mesh info as CSV. And then you'll see all the way down the bottom is something called a radius factor, ERF, on the grid plane. And the grid plane, I should actually call it on the clipping plane. I'll change that. That will be more descriptive. So it's going to be on the clipping plane. And you'll see there's a pop-up just below the cursor that comes up and explains something about this radius factor. So if I now select it and I say yes, it's going to ask me certain things. And the only thing you normally change is what is the block size. Now to run this calculation, I'm going to say 5. So if you change the first one, it will automatically change, and you say enter, it will change the other ones as well. You can change these points manually if you like. But then I'll show you the output. I created a 1 meter interval as example, just to show you how well it looks when you do that. So you create, I'm not going to do 1 because it takes a while. I'm just going to say 5, accept. And what it's now doing, it's create a whole grid of points on that plane, and it looks for the points within the wireframe. It select those. I'll just call this XXX. It select those points and it writes it out as a file. So nothing is automatically going to happen. Nothing happened yet. This file is still exactly what it was before. The only difference is I can now go to marker and I can say, okay, I want to load some marker data. I'm not going to load this XXX one that I now created. I'm going to load one that I pre-created earlier. which I called ERF 1 meter. So that's done on a 1 meter interval. It takes a bit longer to solve. And now if you go to the, if you now go and I take the mesh out, you can see you get a whole bunch of points. At the moment, I color coded on column number 0, which is elevation. Column number 1 is this ERF value that's being, so I'll go to column number 1. So at the moment, it's not exactly what I want, because you can see the stuff in the middle that's bad, that you should be concerned about, is the wrong color. So I'll go to reverse colors, check that button. So now it's the right way around. So now you can see in color what the ERF value for each one of those points are. Now there's a few ways you can then manipulate this data to make it looks better. You can change the point size. So if you change the point size, it gives you a different impact. It gives you a different visual of what you're looking at. You can also go down to that shape drop-down box and create that point 3D, which is like a pseudo 3D point. It's not a real 3D point. And then if I scale it up even more, you get a different visual again. So you can play around with this. And I think this creates quite a good visual if you want to explain a concern about a big intersection at a particular point. What you can also do is you go to the limits, and you set the limits, and you say, well, anything up to 2, or let's say, yep, up to 2 is really okay, and anything above 3 for whatever the value in the mine is, I'm really concerned about, and that shows you exactly then the area of concern for that particular stope. But that's a function of your particular site and what those values would be appropriate on your site. Any questions about ERF? Because the next one about HRs are working quite differently to these ones. Everyone happy with this? Cool.
Frans,
Yes.
have you got any papers or anything? I've never worked with ERF before.
I can see.
So,
Yeah.
so if
there's some papers, yes.
Just a reference to see, I'm going to start working now on massive underground mine project. So it would be interesting to see how that compares to hydraulic radius and what the functionalities of ERF versus HR.
Sure. Can I ask you to just send me an email to remind me? I'm not going to remember.
I will do that. Thanks, Frans.
Sure. Thanks, Rian.
Rian, Ben Barsanti and Peter Andrews did a lot of work on ERF. We used it extensively at St Ives and areas where we've got a lot of staggered pillars. So there's a fair bit of history there, mate, if that's what you're chasing.
Thanks.
I'll get those papers, and I can put you in contact with Ben Barsanti as well, if that's needed eventually. Cool. So when you do ERF, it's normally done for a local location. It's not done yet. It's not something you'll do mine-wide, because the process takes a while if you want to do it to a high level of granularities like this one. But the next function we're going to talk about, the HR function, you can actually do it for quite a significant piece of, for quite a few stopes simultaneously. Actually, you can do it for the whole mine simultaneously. So the next one I'm going to load is just a few stopes. So we've got some stopes. So let's going to ignore some of these stopes. So what I'll do is I'm going to delete some of the stopes. So I'm just going to look at the stopes down the middle. Now to do that, you've on your top toolbar, you'll see the last button, or the second last button. There's something that says delete polys outside rubber band. So if I go for delete polys outside rubber band, and I select my rubber band, so anything inside the rubber band is protected. Anything outside the rubber band is now killed. It's done. It's not there anymore. So all the rest is now removed. So in the file, those objects still resist until I overwrite the file. But in my working file in the software, those other ones are now removed. So the first thing is I would like to differentiate. Let's say for this example, I would just want to and I think this is something that Kobus and I discussed. Thank you, Kobus. A quick way that you can do the hydraulic radius on a particular plane is you can just take a section through the center of the stope. So what we'll do is I'll double click in the center of a stope. So that's double clicking. That will then change this elevation over there in my clipping tool. I'm going to set my step size to 40 because my interlevel spacing is 40, and I want to create a section through the center of every stope. So I'm going to make that 40. I'm going to do a line slipping. I'm not going to do an open poly clipping, a line clipping, and I have to select an uneven number. So I'm just going to select a high uneven number. Why an uneven number? When you do an uneven number, you get one of your sections exactly on the plane that you selected. If you take an even number, it will the one section will be half your step size above, and the other one would be half your step size below that particular point of selection. So make sure it's an uneven number. If I say clipping, I get a few I get a clipping through each one of these stopes, and I'm going to save that out as a separate file. So I call it XXX1. I'm now going to load back those lines, because at the moment I work with polygons, and for this function you can't use polygons, you have to use lines. So I'm going to go to mesh, load, yes, and I'm going to load the XXX1 file. So there's the files. So although it seems like each one of these objects are a separate file, because you can see it's one file with many objects, I don't trust this. I think some of these files are combined, or some of these stopes are combined. So I've got a tool, and what this tool does, it combines connected lines and triangles. So what this does, it will take every line and it will follow the line and close itself. And then if that's a separate unit, it will disconnect that from the next line. So if I do this, you'll see what happens. I'll call this XXX2. Every one of them now have a different color, although it's maybe not that simple. Let's make the line width a bit thicker. So they all have different colors now. I can delete the original file. I'm not going to use that anymore, and I'll just use the latest file. So this file, what I can now do is, because it's all lines and each one of them are separated, I go to mesh, I go to export files, the same as before. I go to mesh info to CSV. Previously, we selected radius factor on grid plane. This time, you select the best fit disk and HR of line objects. You select that one. What this then does, it asks you for a file name, so I'll call it XXX2. And now I can load that file. So again, nothing happens that you can see, but what happened in the background is a file was created. I can now go pick up that file as a marker file, and there's a reason I put it up as a marker file, because I can now look at these as a disk. I can scale it on the value, so that's the size of the disk, and then I can color code it. So you'll see two columns are added. There's a column for HR total, so that means if you've got an HR value or a plane that's not horizontal but at an angle, it will give you the HR on that angle. But it also gives you an HR on plan, which in this case would be the same because it's a horizontal slice. So I can now look at column number 4 or 5, doesn't matter, 4 or 5, and that will give me a distinction between the sizes of the stope. So that's then a summary of all the stopes and the hydraulic radiuses. Any questions on this component? So the next step, yes.
So obviously the example that you've just given us is showing the stopes or you've done the HR, I guess, in the backs or the plan view. Is it possible to apply the way that you've done this to the hanging wall?
So what you can do, I haven't got a good example. So what you could do, I'll just load those files again. So let's assume, I think I understand you correctly, Rebecca. If I don't, let me know. So let's say, I'm just going to, outside, I'm just going to kill out those files again. And then I'm going to save and load, meaning I'm going to save this file and load it again. And then all the changes will be fixed forever. So stope HR. All right, can't do it because this file is already existing. So I'll just keep it. So what you could do, Rebecca, let's say you've got a stope that runs at an angle. So you can define the plane of the angle. So what you could do is you can say, well, I'm going to follow that angle of my plane of my stope visually with my eye. I'll use the clipping tool that uses the camera. And I'm going to create like a clipping through that in that direction. And then you can do exactly that same process on that angle. And then you'll get, again, two columns, HI on that plane, and HR on that plane, and HI in plan view. And you can select which one of the two is appropriate for your case.
Okay, cool.
Is it helping?
Yeah. Okay. Yeah, I'll give it a go and see how we go.
The next step I was thinking of is sometimes what you want to do, you also want to do the sidewalls. and I think, Rebecca, this will answer your question to some extent. So in this case, what I'll do is I'm going to use a vertical selection, is I'm going to make a clipping along the middle of the stopes. I know the step size is not 40 because these stopes are always 30 meters long. So now I have to select 30 as my step size. I'm going to get an output such as this. I'll save this. I'll call it XXX3. I'll load it back. XXX3. Okay, so now I'll do the same step as before. I'll use this tool for combined connected triangles and lines to identify each separate line within the data set. Okay, so now I've got each separate line in my data set. The one thing that you would see is that you have some lines that you don't really want results for. So that green one, for example, you don't really want those points, so you can take those out. So I'll go for the information tool. So that information tool is a toggle. You can toggle it on and off, and that changes the behavior of the software quite significantly. My recommendation is don't put it on if you're not going to use it. Only put it on while you're using it and then take it off. Because as long as it's on, it's picking up a lot of background information, which slows down the program significantly in large files. So I'm going to select the green one. So I can now see it's selected. So I'm going to unhide that one. I'll select the next one. I'm going to add out this one. I'll select this one. I don't know sure what this is. So this is removing the whole stope. So I'm not going to do that one. I'll show you a way to get around that one. This one I'll remove. And you decide which ones you want to remove and which ones you want to keep. So I'm not going to go through the whole process. So that's one. So that's one way. So you can remove some of the noise in that format. The next way you can do, or you can remove the noise, is you can use something called the Delony 2D tool. The Delony, it's creating a surface onto objects. So what this does, when there's noise inside an object, so this is all one object. So it was given as all one, although there's lines in between, it's actually just one object, and I can, so if I select it, for example, and I hide it, that whole thing goes away simultaneously. So what I can do to take some of the noise out, you go to this toolbox, the first toolbox, you take this toggle off, because as long as that toggle is selected as on, it means it will take all the objects in the scene, make one object of it, and then try to drape a Delony surface on top of it. That's not what I want to do. I want to drape a Delony surface on each object separately, individually. So I untick the toggle. I say create a Delony. So I create it. I'll just take the default tolerance. Don't worry about that too much. Select yes to drape the surface vertically down. That's obviously not what I want to do in this particular case. And no to drape the surface based on the best fit plane through the vertices. Yes, so I'll have to select no in this particular case. I'll call it XXX5. And you'll see what this did. What this did is it drapes the surface onto all those points. But for the HR tool needs lines, not polygons. So I need to extract the outline of these polygons now in the next step. And there's a tool for that. There's a tool that says extract mesh boundaries and edges. So we just want to extract the mesh boundary. So I'll select that tool. Yes to extract the boundaries and edges, and no to extract the mesh boundaries only. So I only want to extract the boundaries, so I'll select no. I'll call that XXX6. And now I've got a whole bunch of lines, and you can see much of the noise that I had before is now removed. So if I use this and I go mesh, export files, mesh info, best fit disk and HR of lines and objects, and I call that XXX3. And I load that back as mapping. And I'll show it as a disk, and I'll scale it on value. Then you can see now you've got the HR values for that side of the side walls. So you can get the hanging wall, you can get the side walls, and you can also do it at an angle, as Rebecca asked. Any questions on those? Sure. Can I move on to the next? Yes, yes, Mike.
Just checking, when you've got the HR of the, so you've got the HR of the plane, and then the other HR is always in the horizontal plane, or is in that case is vertical?
I selected it on I can select that angle at any orientation, Mike. So I selected the first one as horizontal for the backs, and this one as vertical for the sidewalls because of this specific stope geometry, but you can also do it at a different angle.
Yeah, and when you get two HRs reported, the one in the last column, is that always horizontal?
So the one in the last column is always the one on plan view. Yes.
Okay.
So, and the reason I put that one aside is the plan view is the one that's fully exposed to gravity.
Yeah,
so
makes sense.
that could always be of interest. Although you can sometimes, well, you have to just select which one is relevant to your particular case.
Good feature. Thanks, Frans.
Not to worry, Mike. Anything else?
Frans, Rian, yeah, do you have a separate tutorial on all the clipping options?
No, I don't. No,
Okay, thanks.
we can talk about the clipping options. That we've got the 30 minutes at the end that we can discuss whatever we like. So I'll discuss the clipping options if that's one of the questions. That's easy.
Thanks, Frans.
Okay, sure. So the next one is open pit reconciliation. So let's talk about open pit reconciliation. The open pit reconciliation, there's a whole bunch of stuff and ways you can do it. So I'll start with the most simplistic way and then work across to the more advanced ways, I guess. So if you take a pit actual, so just any pit shape, doesn't matter. The first thing you can do, and that's what I mean when the information button is on, each time you click on something, it will actually highlight that object and show the outlines. So I normally put it off when I don't need to use it. So the first thing you can do for a very quick reconciliation, when you go to a pit, you want to see what's the state of their catch capacity. So all you have to do, you go to that first color palette, you say color code on poly dip angle, and you say, well, anything from 0 to, let's say, 25 degrees is catchment, and anything on the other side of 25 degrees is not catchment. So I'm going to put the minimum value and the maximum value as the same value. And the reason for that is I'm now just only going to get 2 colors. So that makes it quite easy. Now I get only 2 colors. So when it's red, there's no catchment, and when it's blue, there's catchment. So all you have to do now is you run along the wall and you look for places like this. We have got multitudes of loss of catchment above a ramp. That's always a bad idea. So that's a very quick way of doing some assessment on pit shells. So that's the first one. The second type of reconciliation process you can follow is you can also load the design shape. And then you can compare the one against the other one. Now the tool to compare the two between themselves, now there's 2 options. The one is you color on the closest distance from the mesh, so that would be the closest distance from the one mesh to the other, or you can do it on a vertical distance from the mesh, but the vertical one takes quite a bit longer, and there's long reasons for why that is. So at the moment, I just want to see how closely is the pit shell conforming to the design pit. So I'll select this one. If you select, I'm not going to do this, but if you select 0 to, let's say, 2, it will, so if something is 2 meters away from the design shape, it will be the same color. So there will be no differentiation between the back side of the design shape or the front side of the design shape. But if I select -2 to 2, then it will actually pick up that differential, or if it's on the back of the design or the front of the design. But for that particular application, your design shape needs to have polygons that's uniformly correctly. So they all have to show in the right direction. And that's discussed in the previous video, so I'm not going to go into that again. So I'm going to accept. I'm going to click on the mesh that I would like to color. So let's see what happens. So what happens is it takes the mesh that I clicked on is now testing itself against the design mesh, and it will color code itself based on the design mesh and the distance from that mesh. So I'll hide the design mesh, and now you can see. So everything that's red, if I put the design mesh on, is at the back side of the blue. So that's overbreak. So all the red is overbreak, and all the blue is underbreak. And again, you can go along your wall and have a quick assessment of the outcomes of your blasting. Any questions about this part of this is just a visual reconciliation. This is not a process that gives you any numbers. We'll get to that in a short while. No questions? So the last process I'll talk about is now open pit reconciliation with lines. I'm going to take a very simplistic shape. So normally what you need to have is toe lines and crest lines, and you have to have design lines and actual lines and so on. I haven't got it for this shape, so I'm just going to show one of the features that we talked about earlier. So what I'll do is I'll take this shape and I'm going to generate my lines that I'll use for the demonstration from the shape. So I'm going to say extract mesh boundaries and edges. This time I'm going to say yes, I want to extract the boundary and the edge. So I'll say yes, not previously it was no. I'm going to say the moment the angle between two polygons exceeds 45 degrees, I would like that to be defined as a line. You'll see what happens shortly. I'll call this XXX7, and you'll see what it does. So what it does, it creates these lines from the polygons based on the angle between the polygons. So now I can use one of these lines. So I'll select one of these elevations, and I'll use that for my demonstration. So I'll use this tool, delete polish outside rubber band. So I'll delete, I'm just going to extract that particular level. So all the rest is now gone. I'm just going to clean it up, that piece over there. Just want to get rid of those, delete polygons inside rubber band. So I'll take that out, and I think I missed it. Let's do it again. And then this portion, because that's where the ramp comes down, I'm going to discard that portion. So I'm not going to use that for my selection. So this is the piece that I'm going to use for my demonstration. So I'm going to compare the one line against the other line to see what's the distance is, so I can actually put it in a chart or something similar. So at the moment it's one object. So I'm going to save this out. I'll call this YYY1. And the first thing you would like to do is, because it's one object, you want to split out the two objects. There's two separate objects in this, and I want to split them out. We'll do it the same as before. So I'll go for, what was it? Combined connected triangles and lines. I'll call this YYY2. And now you see I've got two separate, I can now kill the first one. So I've got three objects. One of these objects is most probably, let's see what it is. So that's the first object. So the first and the last is actually the one object, and the middle one is a separate object. I'm going to combine those two objects. I don't want to split them up. I want it to be one object. So what I'll do is, under my toolbox, I'm going to say combine objects into a single object, and it will only function on what's visible in the scene. That's all the GEM4D functions are supposed to operate in that fashion. You only, whatever you do is only applicable to what's visible on the scene. So combine the two. I'll call it YYY3. So I'll use YYY3. I'll use those ones, and I'll remove the ones I'm not going to use. So those are now my two objects I'm going to use. The one could be a design line, the other one could be an actual, or the one could be the one side of the ramp, and the other, well, not the ramp, the one could be a crest line and a toe line if you want to see the catch capacity and so forth. It could be any two lines. It doesn't matter. So you've got two lines. So one of the lines are going to be a baseline that you're going to measure from, and the other line is going to be your interval line that you want to use for your calculation. So I'm going to use my baseline. I'm going to use the outside line. So I'm going to use the outside line, and at the moment the line vertices, if I check the line vertices on, you don't see it much, so let's just, is there so many vertices on it, or why don't I see the vertices on it? I'm not sure why this vertices is not showing at the moment. Oh, there they are. I'll just make the background black, then you'll see it. So you can see there's the vertices on those lines. So for the baseline that I'm going to measure from, I want to subdivide that into many, many points. And the reason for that, I'm just going to open up a tutorial that I'll put on my website very shortly. The reason you want to do this is shown there. The reason you want to do this is when you do your, is it now up or down? I think it's down. This one. Why is it jumping? Not sure why it's jumping. So I'm struggling, aren't I? Oh, there it is. So the reason you want to do this is, so the one line you're going to subdivide into many, many points. The other line you're going to subdivide into fixed intervals like 5 meters. And when that line that you subdivide into 5 meters is the one that's going to then search to the other line to find those locations. Now, if these points are far apart, it's not going to give you the perpendicular distance. So you have to subdivide this outline into many, many points. Then you get a very close to perpendicular distance when you do that search from the marker line that I'll show shortly. So I'll make this tutorial available on my website shortly. So to subdivide this line, you go to the second toolbox and you say split lines into fixed lengths. And I'm going to split it into really, really small intervals like 0.1, 10 centimeters. I'm not going to explain this at the moment. It's a spline, and I'm just going to use a very stiff spline, which is a value of 10. And I'll use this, and I'll call this YYY4. And you'll see it now looks different, but if you zoom in, it looks like a thick line, but it's just because there's a lot of points, and you can see it's not perfectly done, but it's close. So there's some rounding errors happening in the process. Okay, so I'll delete the first one. So the second line, this one, I want to subdivide into a fixed interval. Similar process to before. I want to split this one into 5 meter intervals. And I'll call it YYY4 or 5. Okay, now I've got this one as 5 meter intervals. And I've got this one as many, many intervals. We have many, many small points and small intervals between them. So this one on the 5 interval scale, I'll save out as a marker file. So how you do that, you go to Mesh, Export Files, Mesh Info as CSV, and then you say, I want to export the line vertices as survey lines. Not as survey lines, I'm lying, the one above. Polyline and point vertices, sorry. Polyline and point vertices. You just want to export the points. You don't want to export the lines, only the points. So I'll call that XXX4. So now I can now this string I can remove. I can only bring back the previous one. I'll bring back the markers from the previous one. And now the process is basically done. I'll just make them a bit smaller for the moment. So all you now have to do is you go to markers, you say marker actions, you say distance, and you say add a grid distance column. So I'm going to add a grid distance column. It's going to ask you for 2 options, and you can read the options at your leisure. The answer that we need for this one is yes. And what this does, in your marker column, you can see it added quite a few columns. So in your marker, yeah, it added quite a few marker columns. The one is the full XYZ distance, meaning that's the full distance from the point to the closest point on that outline at the outside. The other one is a distance in plan view, just on the XY plane, and the last one is the distance in the Z elevation. So what you normally use for this exercise is number 4. So I'll color code it on number 4, and that is your PIT reconciliation. And you can see down the bottom, that's your histogram for your distribution, and there's all your statistics for that particular bench that you worked on. Okay, let's talk about the clipping that Rian asked about. And if there's no other questions, that's going to be the last discussion point. So let's look at the clipping. So clipping, the first clippings is quite intuitive. I think there's horizontal, northing, easting. So if you say horizontal, you just get horizontal clipping. And if you say, I'll just have to unclip northing, easting, you get a northing, easting clipping. So I don't think that's anything to explain. The only things to explain maybe is what I mean by step size. So the step size is the size between the lines if you create more than one line, or if you create open polygons. So let's say, for example, you do a section like this, and you set your step size at 5, and you then use these arrows to cycle through your pit. Then it will cycle through in 5 meter intervals. And if you make it bigger, if you make it something like 30, then it will cycle through in 30 meter increments. So that's what the step size is doing. The clipping width is just the clipping width. So that's how wide the clipping is. So if you do a clipping, so at the moment it's 10 meters wide, and I can make it 50 meters wide, then it looks different. Or I can make it 200 meters wide, then it looks different. So that's the purpose of the clipping width. And the clipping width has no meaning when you work with lines, for example. So then the clipping width has no meaning for that particular exercise. Now, the ones that's a bit more useful, I think, in most cases, is the vertical option. So if you select vertical and you select new clipping, you'll see the mouse cursor change to a cross. It's not a mouse cursor anymore. And if you click 2 points, it will just use those 2 points and create a plane from those 2 points vertically down, and you'll get a vertical clipping. So vertical clipping, I think it's quite intuitive and easy to understand. What's not as intuitive and easy to understand is maybe the one we'll get to from now. The next one is the 3-point clipping. So what you now do is you just clip on 3 points on the surface, and it will create a plane on those 3 points. So that's the 3-point clipping. And then the camera clipping is doing the clipping in line with your camera view. So your camera is your eyes. So the way you look into the scene, that's your camera. So if I say it's a camera, I say new clipping, it's gonna use the 2 points that I now select, and it's then gonna clip it on those points in the line of my camera. So in the line of what I'm looking at. So that is what you'll get. Rian, is that helping you?
Yes, Frans, I figured out most of it. One question is, say, for example, if you clip like a vertical clipping, it clips through the whole scene. Whatever on the screen, it shows everything. But let's say I only want to look at a portion of a tunnel, and I only want to look at 100 meters along the tunnel. I don't want to look at the full view. Is there a way to do that?
The way you would have to do it is you'll have first, so the short answer is, well, there's a way to do that, yes. So the way you would do that is the following. You can do it in one of 2 ways. You can first put up some of the objects that's in your way. So that's the first thing you can do before you do the clipping. But let's say that's not an option. So let's say I do a clipping such as this, and let's make it a polygon clipping, and I'll make it 50 meters wide. So my clipping is different from most software clippings. My clipping, I call it clipping and not a section, because it's not a visual section, it's actually a new object. So after you've done a clipping, you can actually go and save that clipping. So I can go to Mesh, Scene Meshes, and I can save this, and I'll call it ZZZ. And I can now go, so it's just saved an object, nothing else happened. But if I now go back and I load that object that I just saved, that ZZZ, that is the actual clipping as a separate object. So my clippings is not visual, it's a physical object that I generate. So after you've done this, you can decide, I only want a section of this picture. I don't want the full picture. And for that, you use on the toolbar, the second last button, there's one that says split, select, and out by rubber band. So what this does is you select the area you would like, and it's going to cut out within the boundaries of what you selected. And like on those lines, like exactly on those lines. So if I call the ZZZ1, you'll see what happened was there's now 2 objects. The one that I cut out and the one that's remaining. So you can now decide, I don't want this, I only want this, and now you can just delete that portion, and then that's the only piece remaining. This tool is quite useful in multiple ways, this selection tool. If you, for example, take your shift key and you keep your shift key in, you can do multiples of these selections. The way the coloring is changing at the moment is not the way it should happen. It's fixed in my latest version, the new version that will come up. This was a mistake that I made a while ago and I never picked it up. So you'll see what now happened was I'll just have to change the colors so you can actually see what happened. In the new version, you won't have to change the colors manually. It will change automatically for you. But you can see what it did. It used each one of those selections and it split it out as separate objects. And you can, by keeping your shift key in, you can do it multiple times. After you color coded the mesh with any value, that could be from marker values or any of the other functions. After you color coded your mesh, you can export the information. You can go to Mesh, Export Files, Mesh Info as CSV, and you can say mesh face information. And what that would do, it will export the center point of every mesh, as well as the dip and the dip angle of that particular mesh. And it will also, the last column will be whatever the color coding was done on. That will be part of it. So let's do it. So if I save this file out, and we'll call the ZZZ4, and if I now load this file back, I can actually load it back as mapping data. So if I load this back as mapping data, I'm going to reset the color of the mesh, or I can just take the mesh out of this. So now you've got the points, And those points, it's mapping data. You'll see each one of those points have a dip direction, a size, an area, a plan area, and a scalar value. And that scalar value is that angle that you were asking for.